So welcome to the part 1 implementation in our tutorials on remote sensing. So in this video I'll be introducing you to the remote sensing software ENVI. Then we'll get started working with some remotely sensed imagery in ENVI. And finally we'll start exploring spectral signatures using the software. So let's get started. So the first thing you'll want to do is go and get the data and put it on your desktop. And my data is stored in the Splinter folder. So I'll navigate there. And then I'll go to GG Projects and down to GG420, Paul Data. And I want to go ahead and copy these two folders to my desktop. So paste. Great, so now that you have the data on your desktop, you want to go ahead and open ENVI. And we'll open this one. And in this tutorial, we'll be using ENVI version 5.0. And this is a great program for working with remotely sensed imagery. So the first thing we'll do is go to Open. We'll go to our mid-air photo, and we'll open the TIFF file. Then we'll open again and back to the desktop, mid-aster, and we'll open the mid-aster. Great. So if you're familiar with ArcMap, you can see this looks a lot like ArcGIS. We have our toolbox here, we have our different layers here, and we can toggle on and off. So if we want to display the top one, we can. The bottom one we can. And then up here we have our basic tools. So here's a zoom in where we can draw a box, zoom in on something we're interested in. We've got a fixed zoom in, and then next to it we have a fixed zoom out. And then finally I can zoom in and out with my scroll wheel on my mouse. So that's what I'm doing now. And here's the pan tool, so we can move around our image. And I'll zoom out a little bit more with the scroll wheel. And I'm going to go ahead and take off the aster image. That's the top image. And I'll zoom in. And hopefully this is starting to look a little familiar. So, do you know where you are? So this is the town of Middlebury. This is Otter Creek. And over here we have Middlebury College. So if we zoom in, can we make out some buildings? This looks like Old Chapel to me. I think Mead Chapel up here. We got the tennis courts, Proctor, Hillcrest. But we'll move down the hill a little bit, and we'll turn back on the aster image by the aster satellite. And we can see that this image, it looks like the spatial resolution isn't that great. So it's kind of hard to make out what things are. But if we toggle between the two images, we can kind of start to make out what things are. So it looks like, for instance, this black is representing the river. These blue pixels, it looks like, are representing the forest. And then here's a parking lot, and it looks like that is being represented by these yellow pixels. So now we can start looking at how the spectral profiles or the spectral signatures are different for these different materials. So we'll go up to Display, Spectral Profile, and we can move this to the side. And we'll go and get our Select tool. And if we click on a pixel of water, a pixel in Otter Creek, we can see the spectral profile for that pixel. So we have 3 bands here, and our first band we can see is located at 0.56 micrometers. So that's about here. Our second band is located at 0.66, so that's about here, and then our third band is at 0.8, which is here. So we basically have 3 reflectance values at these three different points that are connected by these lines, and we can see on the y-axis that we have reflectance as a percent. And if we go and bring up our wavelength diagram and we multiply these values by 1,000, we'll get nanometers. And we can see that 556 falls in about the green region. So our first band here is in the green region. Our second band, 661, falls in the red region. That's that band here. And then finally we have our third band is around 807 nanometers, which is in the near infrared. So we'll take this away for a second, and we can start to see how the spectral signatures change for different materials. So make sure we have our select tool, and we can see that for band 1, that is the band in the green region, reflectance for the water is around 30%. So let's try clicking on a vegetated pixel. So I think this is vegetated. We can go back and check if we look at the image. Yep. And so here we can see that the reflectance for band 1 is a little bit higher. We're up closer to 40%, 35%. And then we can look at the urban scene, so on maybe this building, and we can see that band 1 reflectance is way higher here. And it looks actually, in fact, like the reflectance for all the three different bands, the three different reflectance values are all higher. So we can look at, this is at 45% reflectance for band 2, around 50% reflectance for band 3. And if we click on the water, we can see we're only about 15% reflectance for band 2 and only about 20% reflectance for band 3. So let's look at another place in the Middlebury area, and we'll zoom out, and we can go and look at maybe more rural place. Let's look at these fields. So we'll zoom in here, and it's interesting, it looks like these fields are being represented by this sort of purple color, whereas these fields are being represented, it looks like, by more of a green color. So I'm wondering if maybe there are different spectral signatures for these two different fields. They look really similar if we look at them in the photo, but it looks like they are slightly different according to the remotely sensed image. So I can kind of click between the two, and it's hard to tell because the y-axis is, the scale on the y-axis is constantly changing. But it looks to me like the biggest difference is in band 2. If we look at band 2 for the green pixels, we're down around 30 to 40. And then if we look at the purple pixels, we're always down under 30. And if we go back down to our wavelength diagram, we can see that again we're in band 2, which is in the red region. So that means that pixels here are reflecting more of the wavelengths in the red region than are the pixels here. So if we go ahead and zoom out, we can see that we have different colors in the image, and they're representing differences in the spectral profiles. And that's something that we'll go into more in the following videos. And that about sums it up for this tutorial, but in the meantime you can sort of explore the image a little bit on your own and see how the spectral profiles change from one material to the next, and use the display spectral profile tool. So have fun with that, and we'll talk again soon.